Continuing to practice with our three equations with three variables, let's take a look at this example, example number 2. And when we take a look here, XYZ, XYZ, notice in this first equation there is no X. X has already been eliminated or doesn't exist for this particular equation, this particular relationship. So that's kind of nice. So I'm going to take that and then I'm going to look at these two equations here. I didn't label them this time, but I'm going to work with these two equations here. Since X has been eliminated, I want to eliminate X here so that then we'll have two equations with just Y's and Z's. So taking a look at these two, we have X, 1X, and 2X. So in order to eliminate, this has to be made into a 2, and not just a 2, but a negative 2. So positive 2 and negative 2 would eliminate. So in order to get that coefficient of negative 2x to be able to proceed with our elimination, I'm going to multiply this equation by negative 2. So we have negative 2 times x, negative 2x, negative 4y minus 2z is equal to negative 34. Multiply each of these terms by the negative 2. For this second equation here, nothing has to be done to it. So I'll make my little arrow, but I'm just going to copy the equation as is and go ahead now with the addition. So negative 2x and positive 2x, the x's eliminate. Negative 4y and negative 3y is negative 7y. And in this problem, somebody took pity on us because look what happens here. We were going to eliminate the x's, but the z's also happen to eliminate. So they're gone, and now negative 34 and negative 1 is negative 35. So we're left with this equation, negative 7y equals negative 35, dividing both sides by negative 7, and we get y is equal to positive 5. So look at that. We caught a break. We got one of our variables right away. So now we have to go back. We have y, we need x, and we need z. So looking at these equations we can use for our substitutions, what I'm thinking is this first equation is just y and z. So if I take my y is equal to 5, and I can put it in that equation, so 2y minus z equals 7. Take the 5, put it in for the y. So now we have 2 times 5, 10, minus z equals 7. Subtract 10 from both sides, minus z is equal to negative 3. 7 minus 10 is negative 3. You could have done this another way, so if you did, that's fine. We should get the same answer at the end. And now again, negative z equals negative 3. Variable cannot be negative. Multiplying both sides by a negative 1, we get the answer that z is equal to 3. So now we have y and we have z. We need to find our x. So going back to the original equations, this one won't help us because there is no x. So in this particular example, we have these two to choose from. I'm going to use this one just because it's a plain x, and this one you got to multiply by 2, so it's just a little bit simpler, but you could certainly use this one if you wanted to. So we have x plus 2y plus z equals 17. So x is still not known. 2 for y, we have 5. And now for z, we have 3. So I'm going to put my 3 in there for the z. And now x, 2 times 5 is 10, plus 3 equals 17. And now 10 plus 3 is 13. X plus 13 equals 17. Getting to the end, subtract 13 from both sides, and we have x. 17 minus 13 is 4. So we have solved for our x, and now we have all 3 of our variables. Our answer here, to write it like this, remember, x comes first, so don't be fooled, we found that first. It's x is 4, y is 5, and then z is 3. So that would be our answer.